Yes, check. If we talk about a charge, when in the presence of charge, there will be only electric field. We studied about this in our first chapter. There was presence of only electric field, and magnetic field was not present. When I am talking, when charge is at rest, when charge is at rest means when velocity of charge is zero. But when charge is in motion, when charge is in motion, yes, we can get electric field as well as magnetic field. We will get electric field as well as magnetic field. When charge was at rest, we can get electric field but not the magnetic field. Okay, so this is only the sources of producing the field. So the first point, Faraday's highlighted the concept of field, which Maxwell included into the unification of electricity and magnetism. The electric field is generated by charge q, and it is represented as a vector field. It possesses physical property conveying energy and momentum over time, rather than being an instantaneous artifact. The expression is at E is equal to, we studied about this expression, E is equal to 1 upon 4 pi epsilon naught into q r cap over r square, where what is r? R is a unit vector, and epsilon naught is a permittivity of free space. Epsilon naught is a permittivity of free space. It adheres to the principle of superposition, meaning the field from multiple charges add vectorically. And what will be the force interact? What will be the a charge which is interacting? The electric field E experiences a force. Which force it is? It is the force is equal to Q into E. What is Q? Yes. What is E? 1 upon 4 pi epsilon naught into r square into q r dash. The force depends on charge q and electric field E. Force only depend on charge q and electric field E. Okay, then see, basically what happened initially the thing was, the Oersted was performing an experiment. In that experiment he concluded, I'll draw a diagram. Oersted was performing an experiment in which there was a current carrying wire. Okay, current carrying wire, and that current carrying wire was connected to a battery and a key. This is a current carrying wire. It was connected to battery and key. Yes, it was connected to battery and key. This is a current carrying wire. It is connected to battery and it is connected to a key. Okay, then when you close the battery, there was a flow of current. There was a flow of current. When we are placing some iron pieces or a magnetic needle, we observe that we means Oersted observed that there was an attraction between the wire and this particle, that means iron needle. If there is some attraction, see who can attract the magnetic needle? Yes, magnet can attract the magnetic needle. Magnet can attract the iron piece with the magnetic needle. That means what? That means what? It means that when current is flowing in the wire, the current is flowing in the wire, it will produce what? It will produce magnetic field. So current flowing in the wire is responsible for producing magnetic field. Okay, so who concluded this thing? This was concluded by our Oersted. Okay, this was concluded by our Oersted. Now what? Now, what is the meaning of magnetic field? See how charges produces electric field. In some way, static charges generate electric field. Current or moving charge also generate magnetic field, which is also a vector field represented by B. We have discussed about it. When charge is at rest, it will only produce electric field. But when charges are moving, it will generate electric field as well as magnetic field. Okay. See, we know one thing. We know that charges at rest, there will be an electrostatic force. What is that electrostatic force? That electrostatic force is, yes, that electrostatic force is E into Q. That electrostatic force is E into Q, or you can write it as Q into E. What is Q? Q is charge. What is E? Yes, electric field. And when charge is moving, there will be one more force. What's that force is? That force is magnetic force. And the magnetic force, we have the direct formula. We don't have derivation for this. The formula is V is equal to Q cross B. And we know that when we remove this cross sign, what we will get? We will get VB. If we remove cross sign, what we will get? We will get sine theta. So this Fm was QVB sine theta. Okay, then, but we are using this quantity and this quantity. So according to Lorentz, the combined force is acting on the charge. See, what do you mean? What do you mean by Lorentz force? The combined force will be acting on the charge Q in presence of both electric field and magnetic field, and that will be given by this formula. That formula is QV plus V into B. How that formula comes? See, according to Lorentz, the combined force will act on the charge. So according to Lorentz force, it will be Fe plus Fm. What is Fe? EQ. What is Fm? Q V B sine theta. So this will be equal to what? This will be equal to Q common E plus VB. Yes. We are not considering sine theta here. We are only considering this two equation. So from here, we got the derivation of the Lorentz force, and the derivation is F is equal to Q in bracket E plus VB. It was first introduced by H.A. Lorentz and depends on the charge, velocity, and magnetic field. On what factor it will depend, I will explain you the factors. See, it depends on QVB. See, in this formula we have Q, we have V, we have B. No matter if electric field is varying, there will be no effect of force on here. See, it depends on three things. First, it depends on Q, it depends on V, it depends on B. It depends on this three things. It depends on charge, velocity, and magnetic field. Okay, second thing. If velocity is zero, see, if velocity is zero, this part will get cancelled up. What is that part? That part is QVB. What is QVB? QVB is magnetic force. That means what? If velocity is zero, there will be no magnetic field. There will be no magnetic field means there will be only what? There will be only electric field. So if velocity is zero, that means what? That means when the rest mode is on, at rest mode, your magnetic force will be zero. Okay, your magnetic force will be zero. Now, next is, what will be the direction of that force? The direction of the force will be perpendicular to velocity and B. Force direction will be perpendicular to velocity and magnetic field. Okay, what is the meaning of this? Let's see in the next slide. Okay, so see in this case, B is in this direction. That means let us consider B is in x-axis. Okay, velocity will be in z-axis. See, this is z-axis. This isn't, yeah, you can say it is at certain angle theta. It can be any axis. It should be perpendicular to both, and we know how to find the perpendicular vector. Yes, see, what's the formula is? The formula for Lorentz force is F Q plus, sorry, the formula is, the formula for force is Q E plus V cross B. V cross B. How to find out? It should be perpendicular to velocity and B. See, what you will do, you will take your right hand. See, when you are using right hand, put your left hand in your pocket. Yes, from velocity till B. See, where is velocity? Where is velocity? If you will check, the velocity is here somewhere, and B is here somewhere. Like this it is. Like this it is. So from velocity till B, from velocity till B, the thumb will show the direction of force. Where is the direction of thumb? Thumb is in upward direction. See here, thumb is in upward direction. Okay, like this you can find the, like this you can find the direction of Lorentz force. One more example, let us consider that your magnetic field, let us consider that your magnetic field is in this direction. Yes, your magnetic field is in this direction. Okay, and your velocity is inside. I'm making this dot. Dot means inside, and I hope you know the meaning of cross. Sorry, dot means outside and cross means inside. Okay, so dot, it means what? It means your velocity is outside. So B and V, we are supposed to go from where to where? Always remember the sequence of the formula. Formula is F is equal to Q E plus V cross B. You are supposed to go from V to B. You will be using what? You will be using your right hand. What I told you, the first thing you will keep your left hand in your pocket. Okay, from V to B you have to move. Where is V? V is outside. Outside. Where is B? B is inside. See, V is like this and B is like this. V, this is V is like this and B is like this. I hope you can understand this thing. So what you will do, you will take from V till B. Where is the direction of force? Yes, the direction of force is in the upward direction. Okay, now let's consider one more example. Let's consider one more example. You will give me the answer of this. Yes. So here in this case, you have a magnetic field. You have a magnetic field, and you have, this is your magnetic field, and you have velocity. Velocity is cross. Cross means, yes, it is going inside. So what will be the direction? Velocity is inside. Where will be the direction of force? Anyone? Anyone? Yes. The direction of force will be, the direction of force will be in downward direction. How it is possible? If you will check, B is here, Where is vector? Vector is inside that direction. This is b, this is v, sorry, this is b, this is velocity, not vector, this is velocity. So from where to where you are going to bring your from where to where you will curl your finger, will curl your finger from velocity to magnetic field. How you will curl your finger? You will not go against the nature's law. You will not go against the nature law. Yes, simply turn your hand, and what you will do, you will bring your hand from velocity to magnetic field, and you will find that the direction of force is in downward direction. Okay, then what you have few more information about the magnetic field. The magnetic field is measured in terms of Tesla. Yes, it is measured in terms of Tesla, and it is defined as 1 Newton second per coulomb meter. 1 Newton second per coulomb meter. It is defined as 1 Newton second per coulomb meter. Then the Gauss is another unit. When 1 Tesla is equal to 10 raised to 4 Gauss. Yes. First of all, what is the unit? Unit is Tesla. And what is Tesla? Tesla is 1 Newton second per coulomb meter. 1 Newton second per coulomb meter. Okay, and what about the Gauss is another unit where 1 T is equal to 10 raised to 4 Gauss. Yes, we have given the information about the Dharti Mata, the Earth magnetic field. The Earth magnetic field is what? The Earth magnetic field is 10 raised 3.6 into 10 raised to minus 5 Tesla. The Earth is the weakest magnet, and the magnetic field here is what? It is 3.6 into 10 raised to minus 5 Tesla. Okay, so what we studied in the first point, I will just give you the small conclusion for that. Okay, first we studied that if charges are at rest, it will only produce electric field, no magnetic field. But if charges are in motion, what it will do? It will produce electric field as well as magnetic field. Okay, then what? Then we studied about the Oersted experiment. What was Oersted experiment? Yes. Whenever current is flowing in the current carrying conductor, magnetic field is produced. Then we studied about the Oersted experiment. Whenever current is flowing in current carrying conductor, magnetic field is produced. Then we studied if charges are at rest, there will be electric force. That electric force will be what? Electric force will be Q into E. But when charges are moving, there will be magnetic force, and that magnetic force is what? That magnetic force is Q V cross B. What if you remove cross? It will be Q V B sine theta. Okay, but you will use this vector formula only. What about Lorentz? Lorentz suggested that when charge will be in electric field as well as in magnetic field, there will be a force acting, and that force was named as Lorentz force. Because he explained the concept, because there will be two forces, electric forces as well as magnetic forces. So the Lorentz suggested a new force, and that Lorentz force is what? It will be Fe plus Fm. What is Fe? QE. What is Fm? Yes, it will be QVB. If you bring Q common, you will get E plus Q, E plus V cross B. E plus V cross B. Okay, if charges are at rest, there will be no magnetic force, only there will be electric force. If charges are at rest, velocity will be 0. Okay, so from there we concluded that our force depends on three factors. First, it depends on the charge, it depends on the velocity, it depends on the magnetic field. Then we concluded that the direction of force will be where it will be in the direction of velocity and magnetic field.